Hello and welcome to this video about triangular numbers. A triangular number is a number that can be expressed as a sum of numbers like this. They are called triangular numbers because they can be packed into a triangular shape like this. A fast non-iterative formula for finding the xth triangular number is given here. In this video, we're going to derive this equation, the derivation being a sort of proof. So starting with this proof, we can use this function for triangular numbers that finds the next triangular number from the previous one. We'll assume that the formula that finds the xth triangular number is this quadratic polynomial. Now we'll have to find all of its coefficients. We'll substitute x plus 1 in for x, which is a legitimate step in a mathematical proof. Then we'll expand this expression, and then expand it a bit more. We can finally gather all of the terms together that have the same power of x, and call these the coefficients. We can also substitute x plus 1 in for x into the iterative formula, and then we can gather together the terms that have the same powers of x. We'll just write these two equations up at the top of the screen here. We now have to calculate a0, a1 and a2 from these two equations. We'll equate these two expressions together, which is a substitution. We can separate out all of the terms depending on which power of x they are multiplied by. We'll separate all of the constant terms first. So then we'll get this equation. Then we'll separate all of the x terms to get this equation. Dividing both sides by x gives us this equation, which gives us this simple equation. When we separate out the x squared terms, we'll get this equation, which doesn't tell us anything. It can be simplified to be this equation, and then it can be ignored. I'll just rewrite out these two equations at the top of the screen, which are very easily solved. We can very quickly get this coefficient, then make this substitution, and then get this coefficient. We now have two coefficients, but we still need to find a third. We'll start with the first triangular number, which is really a definition that we can assume to be true. We'll substitute 1 into the polynomial equation to get this expression. After making all of these substitutions, we'll get this expression, from which we can calculate the last coefficient. And so we can very quickly solve this equation to get the value of this last coefficient. Now we have all three of these coefficients and this polynomial equation. After making all of these substitutions, we'll get this polynomial. And after rearranging it a bit, we get this equation, which is the formula for the triangular numbers, which we stated at the beginning, and we're trying to derive. So we've proven that this equation is correct. We can also prove that this equation is correct using mathematical induction. The first step is to prove it true for x is equal to 1. This step is done very quickly by substituting 1 into this formula, so it is true for 1. The next step is to prove it always true for the next number. If it is true for x, then it is true for x plus 1. To do this, we'll firstly substitute the next number, x plus 1, into this equation. Then we'll expand this expression. Then simplify it. Then we'll expand it out again so as to get it into a form that proves this step. We can then split it into two polynomials. And then finally we can back substitute the first polynomial with the triangular number function and simplify the second polynomial. Now we have this equation that resembles equation 1, So if it's true for x, then it's true for x plus 1. The third step is to use the first and second step to say it's true for 1, so it's true for 1 plus 1 is equal to 2, and it's true for 2 plus 1 is equal to 3, and so on. So it's always true for any integer greater than 0. So I hope that you have enjoyed this video and have learnt a lot from it. Click on like and subscribe if you like this video. Please leave all of your advice, thoughts and opinions in the comments. And thanks for watching.